Yeah, okay. So let me formally introduce Dr. Sethi. So yeah, Dr. Tavpritesh Sethi is a physician scientist and an associate professor of computational biology at IIIT Delhi. He is also associated with AIMS at New Delhi. He received his MBBS from Government Medical College Amritsar and PhD from CSIR Institute of Genomics and Integrative Biology. His research is focused on development and deployment of machine learning-based solutions to enable decisions and policy in pressing healthcare questions such as, say, antimicrobial resistance, health inequalities in intensive care, and so on. So yeah, so Dr. Sethi, it's to you. Oh, you are muted, I think. Yeah, Dr. Sethi, you are muted. Yeah. No, we cannot hear you. Somehow you got muted. Any of the hosts or co-hosts, you can try to unmute.
Yeah, I was unable to unmute myself. I'm sorry for that. So I think so. Great. So thank you so much for that kind introduction, Abir. Let me go back to the presentation mode once again. Please let me know if you can see the screen.
Yes.
Okay. Sorry for the glitch, minor glitch. So basically, I would be talking about going forward, how can AI ML enhance the pandemic response or any epidemic response in the country as well as in global situations. So so basically, I'll be speaking about some of the approaches that we have been taking and also some of the approaches that others have been taking in this space. So in my personal, I think I've already you've already mentioned that I have a medical background, then I moved to do a PhD in computational biology. So I've been working in the space of data and ML for the last 15 years or so, and I've been associated with medical institutions. Most recently, we founded the Center of Excellence in Healthcare at IIIT Delhi, which is geared towards building technology solutions, mostly digital health solutions for public health. And that's very exciting. We just started about a year ago in that space, and I think some of our pandemic response has been a part of that as well. I mean, I don't need to underscore this fact that before COVID, this was a slide that I used to show to convince why do we need movement of healthcare as an enterprise to automation of processes, digitalization, and AI-based approaches. But I think now everybody knows that how important are data and models in the guidance of a pandemic response and guiding the pandemic response, right? So in our center, essentially what do we address is we know that there's an infrastructure gap. The major gap is in data, right? So we cannot have an effective pandemic response if we do not have good quality or longitudinal data sets, right? So that's the first gap. So obviously that means that a lot of gaps exist in building data platforms as well as in digitalization, etc. And then there's also gaps in, just give me a second. So sorry about that. So basically we are addressing the gaps in recording of data sets, reporting and planning. And of course we need new devices in the hospital settings to also be able to work. So, and then in our center, we also look at education. Since this is a very recent area, the bridging of artificial intelligence, machine learning and healthcare is pretty recent. And there aren't enough people who actually understand both sides of it. So one of the endeavors in our lab is to actually train more people by skilling, education, and analytics training in enabling such interface training. Finally, the policy gaps. We believe that most of the ML solutions, they basically may need to be fine-tuned for the real-world applications, right? So to be able to build decision platforms so that there can be predictions with them and evaluations. So we do believe that ML needs to actually be tested in the real-world setting, because healthcare is very much a real-world endeavor. So those are the gaps that we actually currently focus on. I'll talk about some of the opportunities, right? So I mentioned that data is at the center of everything, right? And if we think about it, we can think about the way we design our healthcare applications or applications for the pandemic response with structured data, with unstructured data, or maybe even very less data and making simulations, right? So I will start with the structured data, and I will start with the background, because we did not just come into the pandemic response space suddenly one day. Essentially, it was a progress over some years, which started with this project at AIIMS called Safe ICU project. And the goal here was to actually make predictive models that could predict critical outcomes in the intensive care settings. We focused ourselves on the pediatric ICUs at AIIMS, and essentially we said that there is a large gap because ICUs generate more than a gigabyte, or depending upon the size of the ICU, a gigabyte to 5 gigabytes of data per day, routinely generated, routinely lost. So there's a data gap, there is a model gap, right? And then it's a real world situation where we might need to, for example, take real inputs from clinicians. So this is slightly older slide. Now we have more than 1.7 million patient hours of continuously monitored data from the pediatric ICU at AIIMS. And this is how we started. We started really lean by building FHIR HL7 based interfaces, right? And writing our own software, which could enable quality data to be collected. You can see that the quality of the data here, initial quality, you can see so many fluctuations, many times the sensors would go off and so on, right? And what we did here was essentially since we were building this from the ground up, we were able to build in some of the quality parameters in the pipeline. So for example, if the sensor is off and we are not getting the data from a certain sensor, we would get a mobile phone alert that this bed needs attention. So that actually allowed us to gain some initial insights. And when I say, I think one of the important features in healthcare analytics and ML is building trust with the stakeholders. Here, our major stakeholders were clinicians, ICU intensivists, and if we just go into ML models and AI right away, it will not be adopted. So essentially, we started looking at these very simple dashboards, exploratory data analytics, displaying them to clinicians so that basically it becomes more transparent and trusted. And you can see, for example, these are initial days. We would show which beds are not having good quality data. For example, mismatch of patient ID between two sets of data, like the notes data and the monitoring data, right? So these monitoring data are every patient who gets admitted to a tertiary care hospital ICU, they get plugged onto these machines which generate data on heart rate, oxygen saturation, pulse rate, respiratory rate, blood pressure, etc. At every second resolution, sometimes even waveform, right? So we collected these at every second, and then we basically integrated these with the lab investigations and what treatments were being prescribed in the form of notes of the physician. So all this was automated, and we built some initial quality indicators like what is the antibiotic prescription, which antibiotics are being used more, and so on. And then how is the baby or the child doing in the oxygen saturation range. I mean, we don't want babies to be in the wrong oxygen saturation range. If it is too less, they'll get hypoxia. If it's too high, babies' retinas get damaged and they develop blindness, right? So essentially this led to a quality study. Again, this is published now, so slightly older slide. Basically looking at how can these data enable quality assessment in ICU settings. But then we went on to, after about a couple of years of collecting these data, we went on to build models which made use of these high density observations, right? Vitals, heart rates, oxygen saturation, so on. You can see these here, and we asked the question, since we had these vitals, we could score patient every second, right? So we could say, what is the time point at which a patient developed shock? Because we could look at a 15-minute window, and we could look at all the observations within that and say that shock index of this patient was consistently, the median was consistently high for, let's say, 30 minutes. So we took a window size here. And then basically we could go back and create cohorts, right? So this is an observational retrospective cohort building. Now this has been prospectively validated also for saying that this will be our window of opportunity, which could range anywhere between 2 hours to 24 hours. And then can we predict the outcomes from this data? And basically predicting maybe 2 hours ahead of time or 24 hours ahead of time. So I want to say that we were actually, when we say prediction, we actually mean forecasting in a sense, although it's not a forecasting of the same signal, but we don't mean prediction as in predicting tuberculosis from a chest X-ray, because we say that is phenotyping, and from a computational standpoint, it's prediction, but from a clinical standpoint, it's phenotyping or detection or diagnosis. So basically, we used computer vision methods and vitals time series based methods to create models which were predictive of outcomes like shock up to 12 hours in advance. And we started out, again, when we started out, it was lean, very simple histogram of oriented gradients or SIFT features to start with to feed into the models. And the reasoning here, I mean, was the key, that when patients or babies develop shock, there is a certain temperature pattern over the body. Okay, this is taught as a first year medical school understanding that check the hands and feet of a patient. If they're colder than the center, blood redistribution may be happening. So blood is getting redistributed away from the less important organs to the more important organs like the brain, heart, lungs, etc. And so basically there's a gradient of temperature. So we essentially use that understanding to build models. And we saw that these were actually more than just by using these signals, these were more than the PPVs and NPVs were more than 70. The PPVs were about 75%, in some cases 80% as well. So and the AUCs were in the range of 80%. I think I've not put that table in the interest of time because today's main discussion is on pandemic response. So just also to add to this, we have recently used the vitals data to create generalizable models, which have been tested on about 200 ICUs across the US settings and now prospectively validated in the safe ICU at AIIMS. Those are just based upon vitals, and because that's the most commonly available data set. And there we show that domain-based features perform almost as good as deep learning-based approaches. But in some cases, deep learning generalizes better. I'll be happy to talk about it offline if you have more questions. So, but let's come to the main topic of the day, which basically was how do we use these different unstructured data sets in a public health setting, right? So this is a very different setting. It's not an ICU where we could control the data sets and so on. So we have to be agile with data. And an early opportunity that we realized was that we will have to look at data sets that essentially can be created from social media or or literature that is coming out. So a lot of unstructured data will need to actually form a part of the pandemic, informing the pandemic response also. So we will need to be agile with the data, because the administrative data are always lagging. Cases are always reported later, right? But the trends actually happen earlier, right? So in one of these things, one of the early initiatives that we took was we said we'll triangulate various sources of information to build insights for the pandemic. And this is available on a web page called Federated Health Platform. This is a project supported by the Principal Scientific Advisor's Office, and is a collaborative effort between Delhi organizations like AIIMS, IIT Delhi, IIIT Delhi, IGIB, GNU, Ashoka universities. So we are leading the AIML for healthcare in that. And essentially what we realized was that we need to build more data exchange based solutions. So for example, if AIIMS wants to exchange some level of insights in a governed way, with, let's say, Max Hospital or IGIB, right? There has to be some frameworks which can enable this. Currently, we did not have any, so we relied upon the National Digital Health Mission's sandbox to build some of these APIs, where we are building mappers to map unstructured data to the FHIR formatted and NDHM formatted sources. So am I able? Are you able to see my screen? I think.
No, it suddenly went black. Sure.
Yeah, I think the screen share suddenly stopped. So
yeah, you can try to stop and reshare maybe.
Yeah. How much time do I have?
Yeah, you have 20. Oh, no, not. Yeah, 20 minutes around.
Okay, great. No, that's great. I think. Are you able to see my screen now?
It's coming, I think. It's still showing you have started screen sharing.
Okay. Not sure why.
Yeah.
Still can't see my screen?
No, maybe you can again. Yeah. Now, yeah. We can.
All right, and do you see the first slide?
Yes, I'm seeing the first slide.
Yeah, that's weird. Okay, so not sure what happened. All right, so I'll keep talking in the meanwhile.
Yeah, again the first slide.
Yeah. Okay, so I can see the slides are coming up. Let me, I think it says reload. I'm sorry about that. Just let me reload.
Yeah, yeah.
So in this project, essentially what we were doing was we were building a data exchange solutions to triangulate insights from various data sets, such as genomic data sets, because a lot of information about the spread of the pandemic happens. So a lot of information can be gained by looking at the sequences, right? The strains evolving, and then basically also looking at the mutations within each of these strains as they evolve. And so my next slides were talking about those. I think something is, I still don't see the slides come up. I'll take another minute to try again.
If you have the offline version of the slide, maybe sometimes with Google Slides this happen.
Yeah. Let me download a PDF and
In the meantime, I have a question. Maybe I can.
Yeah, please go ahead and ask questions.
So yeah, it is from Rohit. So he says how Bayesian network works in fuzzy neural network and how are they related? Because Bayesian network is directed acyclic graph, but fuzzy neural network is not.
So I didn't get the question. So so are you asking how Bayesian network?
Yeah, works in fuzzy neural network, and I'm not also sure like related to which slide it is.
Yeah. No, but yeah. So I think so. The Bayesian network, as you said, is a directed acyclic graph, right? There is some sort. It's a joint probabilistic model which you fit over the data set. So basically, you're trying to factor the probabilities, right, and the marginal probability into various parent-child probabilistic influences or relationships, right? So whereas a neural network, fuzzy neural network, I don't think it works that way. Basically, it is, first of all, I think Bayesian network is a more representation learning approach. It's if you think about it from the perspective of learning the joint probabilistic distribution, right? Whereas I think if you're looking at fuzzy neural network, you may be talking of more of a supervised learning scenario where there's a certain outcome that you might want to optimize for, right? So or you want to predict. So that's a major difference. I'm not saying that Bayesian networks cannot be used for performing those kind of predictions, but the basic difference is this, I believe. And secondly, I think as you said, if you want to do things like causal modeling, and influence and maybe decision modeling, Bayesian networks are better than fuzzy neural networks in that sense, because those will be typically more observational and association models that will come up. Are you able to see my screen now?
Yes. Yeah.
Okay, great. So all right, so yeah. So I'll come back to that question when we actually talk about the Bayesian networks later. So on this platform that we were talking about, the key idea was that how do we build models? How do we build models upon heterogeneous data sets, right? And you can visit the link. I'll not spend more time on it. On how do we enable the consent framework? For example, saying that if a hospital wants to exchange data of COVID patients with another hospital, we just can't start building AI/ML models on top of it. There are regulations about how patient data can be exchanged. Consent frameworks need to be kicked in. So on this, basically, we have these two-layer consent where patient has to give consent about exchanging their data. And then, of course, the hospital then can exchange the data as well. All right. So, and then some of these solutions that are on the platform, one of these which I'll talk about is called strain flow. I'll also mention evidence flow and vaccine. So I said that in pandemic response, there's multiple sources of information. You could look at cases data, sequences data, social media data, and so on. And these are three different use cases on the platform, which basically highlight some of these. Okay. So the idea behind strain flow model was this, that you can actually read the sequences of a virus, spike region of a virus, just like you learn to read text, because these sequences, these nucleotide sequences are represented as text. And these also have words, right? These words are called codons. Every 3 bases code for a certain protein in the virus. You may have heard about spike protein, right? So, they code for a specific amino acid that fits into a protein in the forms a protein in the virus, right? So for example, each of these triplets will form an amino acid, will code an amino acid, which will then be a part of the protein. So when we talk about virus strains emerging, like the Omicron strain or the Delta strain, new strain, etc., what happens is that these multiple coordinated mutations happen, in this underlying sequence in the virus, right? And we said that since none of the existing models look at the context, right? Can we use models that build some context of the sequences? The reason being that when these mutations happen, evolution works in a way that they happen in a coordinated manner. Optimization happens in a way that basically virus will have multiple mutations, which will allow that to thrive, okay, essentially in a given situation. So basically we said that there may be some long range correlations within the mutations, etc. So can we actually make use of models which are used in text representations, and then develop some of the features that may help us predict how may the cases change in the next 2 months, okay, or 1 month. So basically, we started with very simple word-to-vector models, skip gram models, where we optimize the number of dimensions by looking at information entropy, and we looked at how many dimensions should be used to encode a 1200 base pair spike protein region. It turned out to be 36 dimensions, and in 36 dimensions, essentially, we represent the viral sequences. We did this on 0.3 million. Now it is more than 1.5 million sequences that are available on GISAID, right? And then we essentially initially did some preliminary analysis to see that are we capturing these relationships. So each viral sequence will now have an underlying vector representation in the model. And using that vector representation, we can actually calculate the distance between one sequence and another. And this distance can be used to construct this phylogenetic map, which actually captured in a totally de novo fashion. We were not looking at any expert understanding in this, how the viral sequences changed in time. So this captured temporal as well as geospatial relationships, like how are sequences related in UK or and different in India and so on, okay, and the temporal variations also. And then we asked the question that some of these 36 dimensions can be leading in a causal analysis. They can be leading the prediction of cases, because we know, biologically speaking, some mutations, when they happen together, they confer more transmissibility. That's what is happening in Omicron right now, right? So essentially, we said that can we look at those dimensions, which in a lead-lag relationship with the cases are more predictive. And we use features such as entropy of the dimensions, what is the entropy of the underlying dimension and how is it changing? And we use a time series of the entropy to see the relationship with the cases. And we saw that on the right-hand side, you can see that entropy of selected dimensions, which we call dimensions of concern, actually led the rise in cases in many countries. And now this makes sense. If you think about it biologically speaking, when cases are going to rise, what is happening is basically a new strain is, so it's an explore, exploit thing going on, right? So first the strain will explore, entropy will increase, right? And then suddenly it will start falling, which means a strain is getting now evolutionary advantage and it is getting established, right? So that's what you see happens in a leading fashion in this. It first explores and then it exploits, and basically this is what happened for Delta. And this is exactly what we are seeing now for Omicron. Also, we don't have enough data from India, but we have enough data from other countries, and our models actually capture this relationship. So we were able to basically build predictive models, which were able to predict up to 2 months in advance. So for example, here you can see that this relationship happens in up to 2 months in advance. And that's what we are using on our strain flow dashboard, right? So I have the most recent version of the strain flow dashboard. You can visit and see some of these changes are actually predicting the Omicron and the cases in UK and Germany. For India, as I said, we have little data for the month of November currently. I'm informed that the data have been uploaded now, but from October's data, we were actually capturing the upticks in number of cases. going forward before any of these information about Omicron actually came in. And that's visible on our strain flow dashboard. Okay, I'll skip this, basically saying that another area that we were looking in the early stages of the pandemic was, how do we build these information models, right? How do we gather information and use that to provide more information to people where it matters the most? Essentially, the core idea was, how do we build the right information, bring the right information to the right people in the right format at the right time? We realized that early on, when the pandemic struck, people were not having access to information, right? WHO was putting out something, but most of the information that was being relied upon was in news, right? So the Ministry of Health and Family Welfare sources and the WHO sources were putting out something, but people are not looking at that. People are looking at the news, and news is full of misinformation. So one of the earlier projects from the Safe ICU project was called Wash Karo, where we were looking to provide information to mitigate sepsis in the community settings, right? And what we said was, we should be able to actually provide relevant contextual information, match it with what the WHO sources are saying, right? We summarize them using some text summarization approaches. We generate similarity scores. We use human in the loop approach, where basically humans, clinician experts say that these similarity scores are performing better. These similarity scores, for example, cosine similarity versus Jacquard versus other similarity approaches, we pick the best similarity matching algorithm. And then basically we use translation and text-to-speech API to provide information to people about sepsis, right? And then they can say thumbs up or thumbs down. Now, this became important when COVID struck India. We repurposed our pipeline to COVID. Okay, there's certainly gaps because I mean, so at a high level, what we are trying to do is we are using matching approaches with what WHO is saying, with what news are reporting, right? And then we use some human layer of vetting in between to provide the right information, right? But it actually allows us to filter a lot of misinformation, and that's what we were doing in the beginning of the pandemic. We showed that, and this is now accepted and published in scientific reports, but the preprint is available online. You can look at the most recent version. So we showed that as people used our app for COVID, there were about 11,000 people who were using the app for COVID-19 and gave thumbs up or thumbs down. Our relevance scores actually keep on going up. So this was a first public health intervention system using machine learning for filtering out misinformation and providing them to people in their own format. So we provided this information in Hindi, right? So you can imagine the challenges of multilingual information matching, and so on, right? But we saw that our relevance scores kept on increasing over the time for which we were online. What happened was, at some point of time, Google pulled the plug on all COVID-19 apps. Only governments were allowed to spread information. So our app was also taken off. So we could not provide more information on COVID. So we were online for about 3 months. But then basically we appealed, and our app is now repurposed for tuberculosis, and we are online, and there we are building some of these strategies for COVID. But in those 3 months, we could see some very interesting insights. For example, more females engaging with the app in Hindi than males, right? We did not have personal data, age, demographics, etc., but this was a basic information that we had, right? And more males in general using the app. So telling us that there's need for more inclusive models to be built when we are thinking about AI for public health scenarios, right? Very early insights, but these are published in scientific reports. You can go and read more about these. We look forward to actually rolling out some of these models on a larger scale to conduct pilot studies to understand how public health responses can be facilitated using such machine learning approaches. Okay, so we also used models to gather evidence across literature. If you remember, during the pandemic response, hydroxychloroquine was one of these drugs that came up early, right? But then it fizzled away. Similarly, ivermectin, there was so much misinformation about ivermectin and hydroxychloroquine. So we built this pipeline where we looked at WHO vetted articles, and we used this approach where basically we performed biomedical named entity recognition, built word embedding models, okay, and basically using those word embedding models, we looked at the relationship between the biomedical entities that were coming up, like hydroxychloroquine or ivermectin, right? And then these entities basically were mapped to a network. Modularity analysis was done, and then we basically built longitudinal networks and did link prediction of what may come up next as emerging evidence, but also what is gathering evidence over the last few months. This paper is under advanced stages of review, but you can again read the preprint online, and the dashboard that is updated is available as evidence flow dashboard. And we show that we were able to capture early insights about things like blood clotting disorders that may be associated with COVID. Right now, we are looking at insights about psychiatric complications, neuropsychiatric complications, and going forward, we are keeping an eye on what's happening with vaccine. Right. Yeah.
Sorry to interrupt, Dr. Sethi. So, yeah, I mean, we are a little pressed on time. So, can you please quickly wrap it up?
Sure. I'll conclude in the next 2 minutes.
Thank you.
Yeah. So, I think finally I'll talk about opportunities for resource allocation. I'll skip this slide. All of you know what is reinforcement learning, and I believe all of you know about how the reinforcement learning based algorithms in AlphaFold 2 are changing the game in drug discovery. I'll skip this, right, where you can go and read more about the AlphaFold algorithm. And it's now been open source. So if you're interested in drug discovery, I think it's a very major breakthrough in the field. But we were asking this question with reinforcement learning: can we develop better vaccine allocation strategies across the states of India? Okay, so again, you can go and read the paper online, again in advanced stages of review. Hopefully should be accepted soon. We talk about contextual bandit and a deep queue network approach, context being number of beds, number of ICUs in that state, ventilators, etc., right? And then basically defining reward functions, the network learned, and we show that we always have a positive number of cases prevented if we take such an approach over what the current approaches have been, or if we took a naive approach. Okay, I think I'll skip the details of the algorithms, but they are available as a dashboard also, and also as algorithms that we are open sourcing for public use. Okay, so finally, I think causality is key to deployments. Unless we can, I'll skip all of this because this is background, but unless we can build models that can be explained to clinicians or to policymakers, and can have some of these effects like mediation effects, which can drive causal, or discover confounding, or know where there may be a competing hypothesis, right? We will not be able to actually gain the trust of the policymaker or the clinician, right? So in that space, we have been working with Bayesian networks, more recently with graph neural networks. But I'll skip this. This is not pandemic response. Just to say that in this particular case, we built models that helped us to gain insights on what could mitigate airway diseases at a population health level in India, and more recently in a project where we actually looked at how HIV spread can be mitigated across 5 different states of India. This is in collaboration with an organization called Swasti, and it was supported by Google Research India. And essentially, it led to some very interesting findings about interventions that could be learned only by causal approaches. So to summarize, I will just say that there's a broad range of applications that you can imagine with AI, ML. There's a broad range of approaches also, right? In terms of structured, unstructured, triangulating information, etc. And then you perhaps could look at some of these new approaches that are coming up in mining evidence from unstructured data, combine it with structured data, and then basically build causal models. I'll stop here, and I would like to acknowledge all my collaborators, funders, and supporters, especially for the pandemic response projects. And these are some of the students who have been working with me in this, and some colleagues who have been working in this. So I'll stop here and take questions. Apologies for, I wanted to end up at 10:10, but yeah, I believe we still have time for questions.
Yeah, thank you, Dr. Sethi. Yeah, so we'll take one or two quick questions. So the first question is from Sovik. So he says, how can a virus genome exploit? Is it not random changes as suggested by Darwinian theories? Or have you noticed that the entropy in particular areas of genome responsible for the variant generation decreasing after establishing the variant?
That is also true.
Yeah.
So that is also true. I mean, so basically some dimensions, if you think about, so to answer the first question, Darwinian theory, it implies towards random, but but there is also selection, right? So when the selection comes in, the evolutionary advantage conferred by certain mutations establish that strain, right? So there's mutations happening randomly all the time, but then there's selection. That's how these strains get selected and established. Otherwise, there would be just random coming up of strains. So you can see that some lineages have completely replaced the other lineages. Delta has replaced. Now Omicron is likely to replace Delta and is fastly replacing Delta in many countries. So although it is random, but there is also selection, right? So that is the first thing. Secondly, to basically selection to operate, right? It has to first explore and then exploit some of these changes and then get established. But this establishing takes some time, right? So basically, we are not saying that we are predicting which new mutations may come up. Although we are currently also working in that space where we are doing BERT models for looking at what can we predict. But currently, in this particular model that I showed today, was just a model to capture early changes that could lead. So we are not saying that we are predicting future mutations. We are saying that some mutations are indicative of selection early on. All right, and that can biologically be explained from the standpoint of if your receptor is binding more strongly, spike protein is binding more strongly to the receptor, it might get established faster, right? So that lead time is what we are looking at. And then there's some, for your second question, there's some mutations that will happen as a downstream effect of when a strain is has gotten established. So that is also true. Both sides are true. That is why we said we looked at a causal analysis of 36 dimensions. We found 6 dimensions which were leading. All the rest were lagging. I hope that answers the question.
Thank you. So one last question. There are lots of interesting questions. I would request the speakers to go through the Q&A, but yeah, one last question I'll take. It's from Ajay. So he asks about the roadmap, what steps are necessary basically to go from predicted healthcare to preventive healthcare.
That's a very broad question, but I think from predictive to preventive, we first need to have understanding of health in general, right? And right now, health data are very sparse. So I think it will begin with data. It will begin with the data quality initiatives and having these observational studies record data, and then essentially seeing interventions from observational to interventional studies, which basically build in more understanding of what could be the causally preventive interventions in this space. So I believe we are far away right now from being preventive with our approaches. we are even far away from predictive, to be very honest. So I think right now we are in the observational state, descriptive. Slowly we are moving towards predictive, but as we gather more data and as we make healthcare data-centric, there will be more preventive understandings coming up. But yeah, so I think there will be multi-pronged intervention required. I'm sorry I could not answer all the questions. Please feel free to reach out to me on my email or my LinkedIn, and I'll be happy to discuss it further. Happy to answer questions or discuss projects.
Thanks a lot.
Thank you, Abir. Thank you, everyone.
Okay, I think we will now move to the felicitation and the result announcement. So I'm not sure who will take over from here.
So Jayesh is going to take over. We're just looking for him, I think. Oh, okay, there he is.
Okay, thanks.
Jayesh, you can start.
Yeah, I'm just sharing my screen. Second. I'm not sure why do I not see that.
Share screen, you cannot see.
I'm not sure, it is asking for me for some privacy related things.
I can share the screen for you.
Yeah. Vidisha, if you could.
No, because
Right. Yeah. So yeah, hello everyone. Very good morning to all. And we are here to present the Datathon awards, and this is for the set of remaining competitions, which were multilingual abusive comment detection and the Indo-Ari. So let's move on to the first one, and the first one is multilingual abusive comment detection. This was majorly, or the data was shared by ShareChat, and the data comes from a website or an app which is a short video making app called as Moj, and the data is about the comments that are posted below the posts, which are the short videos on the app Moj, and the goal here was to identify whether a particular comment is abusive or not. And the comments could be in different languages, which are mainly written in English, but the basic language could be different. Here, the training data or the data that was given to the participants to train the models were around 1.5 million comments, and the test data was also a good enough size, which was around 600K comments. So yeah, this was a main part of the competition, and there were a number of participants over here. Around 40 participants submitted their results, and out of this we have got three participants who make it to the top with a good enough scores, and these are the winners of the competitions. Harbin, with a team name Harbin, and there is only a single for all the three winners. There are only single members in each of the teams, and those are Harbin Singh Chadda, Ekagra Ranjan, and Naman Poddar. So in order to do the felicitation, I would call upon Devdut Mukherjee, who is our guest for today, who is also a AI lead at ShareChat. Should we move on to the next slide, please? Yeah, it's my pleasure to invite Devdut Mukherjee over here. Devdut Mukherjee is a AI team lead at ShareChat and Moj. Before this, he was also working at Hike and also at Myntra, tackling a number of data science related problems. And he has also worked at IBM Research, investigating the problems related to enterprise search and information extraction. Devdut is interested in number of areas related to ML and AI, such as recommender systems, information retrieval, machine learning, conversational modeling, social network analysis, social graph mining, and whatnot. I think I will move on to, or give it over to Devdut to tell us more about the ShareChat data and his work, and also felicitate the winners then. Devdut, yeah.
Yeah, thanks, Jayesh. Good to talk to all of you this morning. Yeah, as just mentioned, so we are a company that runs a couple of social media platforms, ShareChat and Moj. ShareChat is the largest regional social media platform available across 15 Indian languages, right? So the app was born with the mission statement of creating a much more inclusive social media. Back when it started 5-6 years back, there was very little content available in Indian languages in social media. So with ShareChat, we have come a long way. And we've been able to sort of foster this inclusivity and participation of users in social media. So the entire mission statement really rallies around how can you enable users to communicate and connect and exchange information in a social media platform in their own mother tongue, right? Without like being so in a free manner and in a confident manner, right? And to be able to do that, one of the pillars also is to keep a platform safe, right? And trustworthy. Only when people find safety and trust on a platform would they communicate freely, and the platform would grow. And like the competition that we have created here is very much linked to that particular pillar of trust and safety. So we work on a wide range of trust and safety problems. Most of them are multimodal in nature, around detecting nudity, violence, different kinds of baits, and so on and so forth. This particular competition was specifically focusing on identifying abusive comments and abusive text, which is posted on these platforms. And we took the data from Moj. Moj is India's largest pure play short video platform. So yeah, and congratulations to the winners, but thanks to everyone who participated and put in efforts on this competition. Thank you. Back to you, Jayesh.
Yeah, thanks a lot, Devdut. We'll just move on to the felicitation of the winners here. And yeah, so the winners are, as we said, Harvind Singh Chadda. Let me just put Harvind in the. So can Harvind open up his video and then?
Yeah, hi.
Yeah. Yeah. So here is Harvind Singh Chadda, and yeah, he's a first or stood first for after submitting all the results and for the competition. And the next winner is Ekagra Ranjan. So can I call upon Ekagra Ranjan?
Yes, hi.
Okay, yeah, hi. See him. Okay, and the third winner is Naman Poddar, but I think Naman is not present for the meeting or the chat here.
Yeah, hey.
Okay, yeah, hi,
Here.
hi Naman. Sorry, we could not see you before. Yeah. Okay, yeah, hi. Thanks, Naman. Thanks for
Hi.
coming. Okay, So let's move on to the next competition, and the next competition was Indo-ARI, where the goal was to predict the relation between two entities that are present in the sentence, and these sentences could be again in three different languages: Bengali, Telugu, and Hindi. And the data set was of around 10K training instances, that also again in three different languages, and there were 25 different relations that were present. The participants were also provided with an additional data dump, which was basically to learn more things from the data, and which was not directly related to the main data set in the training. This we would also like to thank the authors of the co-NL paper, which was published in 2021, and there was a lot of help from Arijit Nag from IIT Kharagpur, who helped us in going over the data sets and understanding the nuances in the data set. So here as well, we have the same list of winners as that of the multilingual abusive comment detection competition, and those are Harvin, Ekagra, and Naman. Let us again felicitate all of them, and I would again request Harvin, Naman, Ekagra, and Naman to just open up their video and just say hi to everyone once their certificate is flashed out. Yeah. So yeah, Harvin here, and again he stood first, and then Ekagra was second for this competition as well, and then the last one was Naman. Yeah, hi everyone.
Hi guys.
Hi.
Yeah.
So the rank also didn't change.
Yeah. So the rank also didn't change. Yeah. So yeah, the ordered set was same in both the competitions.
If they want to tell some.
Yeah. We'd move on to Naman, Ekagra, and Harvin if they want to say something about the competition and how was their experience.
Yeah, I would like to thank the organizers for hosting this competition. Hackathons are indeed a very fun way to improve and showcase our skills. And kudos to the organizers for taking the feedback of the participants in a positive manner midway in the competition and making visible efforts to improve the competition towards the end. Overall, I'm happy that the competition ended pretty well. Yeah, thank you once again.
Thanks, Ekagra.
Yeah, thanks to the organizers. Yeah, it was a great competition. Like Moj was really first competition where the data is from the real world, and yeah, we have to predict it's abusive or not. So it was a fun competition. So yeah, I enjoyed it a lot.
Thank you.
Yes, I think I would like to thank the share chat and the other people for providing the data set, because it is not daily that you get 1.5 million occurrences in labeled in Indic languages. So that is why this data set was a huge contribution to the open competition, and I think we'll get a lot of good models built on this data set.
Thanks, Arvind. Thanks. So we would also like to thank everyone who participated in the competition and also for their feedback over the discussion forums. And yeah, as promised, we would keep on improving depending on the feedback and also make the competitions better as we go ahead. So I would also highlight the one more competition which is going on parallelly in the IndoML or the Datathon umbrella. This is hosted by IBM Research, and this is specifically towards the COVID-19 data set. And yeah, so here are the deadlines or the key dates for the competition, and the competition ends at Jan 31st. So for this competition, there won't be a leaderboard or something, but at the end, whoever submits the code or the final thing, they would be evaluated differently, or their code would be monitored, and then in March, on March 1st, the winners would be announced. So I would request all the participants or to take a look at this competition. Again, this is a good enough use data set that is given by IBM Research, and participate in this as well. So yeah, thanks a lot, everyone. Thanks for attending the felicitation part, and also I hope everyone is enjoying the IndoML Symposium and all the talks, great talks there. So see you soon. Thank you.
Thank you, everyone.
Thanks, David. Thanks for coming.
Thank you, everyone. Bye.
Bye-bye.
So I'll pass on to Mayank for the next session phase there.
Abid must be Abid. The sessions, yeah.
Sorry. Yeah, I have to do something. Yeah, I was thinking that I have given it to guys.
The session, yeah.
Okay, so we don't have anything else, right? After this. Okay, so yeah, thanks again, everybody. I think we can close this session, and I think the next session is at 3 or
15.
Yeah,
It is at 3:15.
Yeah, so that will be an interesting session on ethics and trust in NLP. So we will all gather here at 3:15. Okay, thanks a lot, everyone.
Thanks.